Okay, let's start by going over group work for Chapter 5. So this was just a summary of all of the Chapter 5 problems that we looked at. So I'll make a key for us. Write the perimeter of a rectangle as a simplified polynomial. So perimeter is going to be, you have 4 sides, so I need 2 of these, 2 of the lengths. So I'm going to have 2 10x minus 3s, and I'm going to add to that 2 of the 5x minus 16s, right? If I double that, I get 20x minus 3 plus 10. Oh, I didn't distribute all the way. You guys, you didn't catch me. 6. 10x minus 32. And if I add my like terms, what am I going to get? 30x minus 38. Good. Centimeters. That's including units, okay? That happened a few times on quizzes and tests. Include the units. Write the area of the rectangle, so this is perimeter equals, as a simplified polynomial in descending order. So area is length times width. So we're going to have 5x minus 16 times 10x minus 3, right? Length times width. What do I have to do to multiply polynomials? Binomials specifically. I have to FOIL. So we have 50x squared minus 15x inside minus 160x, and then last, negative times a negative is a positive 48, right? So far so good. Is that fully simplified? Because why? Oh, our like terms. So what would I get there? X plus 48. What are the units? Centimeters squared. Because anytime you have area, you have square units. So this is the units right here. Okay, so checking over your work. Write each number in scientific notation. We want to write it as a number times a power of 10. So I start with a decimal at the end. I'm going to move it how many places? Yes, I'm moving it 4 places. So I put it between the 5 and the 7 times 10 to the 4th power since I moved it 4 places. Where do I want to move this decimal to? 2.9. I always want to have one digit in front of the decimal. Since I only moved it one place, times 10 to the negative 1. I only moved it one place. The number is smaller, so I always have a negative exponent when my number is small. We always want to have one digit in front of the decimal when we write in scientific notation. So we say that this number is between, we call it A. A is between 1 and 10. It could be greater than or equal to 1, but it has to be less than 10, meaning it would have to be 9 point something, right? It's not less than or equal to 10. It couldn't be 10 because we only want one digit. So that's for that front number. Write each number in standard notation. Now, I can tell right away that because that has a negative exponent, is it a big number or is it a small number? Small. And I'm going to move the decimal how many places? 4 places. So if I put 1, 2, 3, 4 zeros and I put the decimal after the first one, then write the number, I've moved it 1, 2, 3, 4 places. Okay, so I'll put three zeros in front of the number and then the 4th in front of the decimal. Here, since I have a positive exponent, it means I have a big or small number? Big. So this becomes what? 6,220 because we move the decimal 1, 2, 3. Since I have 3 there and I already have 2 digits, I'm only going to have 1 0. Okay, now when we're adding, we want to rewrite these, so we're going to add. We were looking for what when we add? Like terms. Good. Like terms, I'm looking for x to the 20th. Here's another x to the 20th. Negative 4, positive 2, negative 2x to the 20th. The exponent doesn't change when I add and subtract like terms. Okay, here's 3x to the 10th, x to the 10th. How many x to the 10ths do I have? 4x to the 10th, good. And now I have my constants. Negative 11 plus negative 7 is negative 18. Very good. So that's fully simplified. It's in descending order because we have the biggest power followed by the next biggest followed by x to the 0, right? Oh, you don't see it because you have x to the 0. Remember, x to the 0 is the same thing as 1. Okay, over here, when we subtract, what do we need to make sure that we do when we subtract? Yeah, but we need to add the opposite. So we're changing the signs of all of the numbers that come behind. So if we add the opposite, then we can be confident about the signs. So we have negative 4x to the 20th minus 2x to the 20th is 6x to the 20th. Good. Okay, we have 3x to the 10th minus x to the 10th is 2x to the 10th. Good, positive. Okay, now we have negative 11, and this became positive 7. What? Negative 4. Good. Okay, here we're multiplying now, right? Because there's no addition sign here, so we need to use what property? Yeah, well, it's a product law because we're multiplying, we're not taking it power to a power. We're going to use the distributive property, okay? And then we're going to want to eventually put it in descending order, but let's just multiply first. Negative x to the 4th times x is what? Yes, negative x to the 5th. Negative x to the 4th times negative 3x squared is to the 6th. Remember, we're using product law, not power to a power. Okay, and now negative x times negative 3 x to the 11th. Good. Now let's put it in order. Descending order. What's going to go first? Plus 3x to the 6th minus x to the 5th. Any questions? Perfect. When we multiply here, what do we need to make sure we do? FOIL. So 5x times 7x is 35x squared. 5x times 9 is 45x. Negative 1 times 7x is negative 7x. And then negative 1 times negative 9 is negative 9. We want to simplify. Always simplify. So what do we get when we simplify this? Minus 9. Good. We combine our like terms. Here, when we square this, one of the most common mistakes, and it's going to be on your quiz, okay, is that people will want to just say, oh, I'll square x and I'll square 4. But what do we have to make sure that we do so we don't get this wrong? We have to FOIL. X plus 4. Okay, because squaring means times it by itself. When you times it by itself, you get x times x is x squared, 4x, another 4x, and 16. So we call this a perfect square trinomial, PST, for perfect square trinomial. What is this one going to be called once we multiply it out? We want to FOIL it. What is it called in the end? It's going to be x times x is x squared, outside 5 halves x, inside negative 5 halves x, and last, negative times a positive is a negative. What's 5 halves times 5 halves? 25 fourths. You multiply it, right? Multiply it. Okay, what would simplify here? Oh, why are you getting rid of those two? They do. They become 0. Anytime you add something to its opposite, you get 0. 25 fourths, we call this difference of two squares. X squared is a perfect square. 25 fourths is a perfect square because you multiplied 5 halves times 5 halves. It's the same thing. You squared it, right? 25 is a perfect square. 4 is a perfect square. Okay, let's look at the back. This is what really trips people up. Now remember, we always want to have positive exponents in the end. So I was suggesting in group work earlier that you might do something like this, 2x to the fourth, and then apply the negative exponent. What is 2x to the fourth? 16 fourths, right? Or 16x to the fourth. I mean 16 fourths. Okay, if you have what does the negative exponent tell us to do? Yeah. So remember that the negative exponent has nothing to do with the sign of the number. It just means take the reciprocal. Okay? This one is very similar, so I'm just going to go, I'm not going in alphabetical order. I'm going over here. So what is the difference between these two? Yeah, so is the 2 being taken to the negative 4? No, it's not. 2 decides to stay, and x to the negative fourth is moving downstairs, right? Because remember, this is all over 1. So the only part that gets the reciprocal is that negative exponent. Okay, let's look at this one. What should I do first? Yeah? So take this to the third power. We have 125 a to the 15th times 2a to the negative 7th. What should I do? 250, because 125 times 2, yes, and then a to the 8th, because 15 minus 7 is 8. You could have also taken the reciprocal on the a to the 7th, but because we're just going ahead and adding the exponents using the product law, we end up with a positive exponent here when we add. Okay, let's go. I guess we'll go. I'm going back and forth, so we'll go here. Now, somebody noticed something right off the bat. What did you notice, Daniel, right off the bat about this one? Yeah, last. Yes. So it's 1 because of the 0 power. So now we could just deal with this part, right? So 4 times negative 3 is, and then what is my x going to be? X to the 19th, y to the 13th. There we go. Times 1 is just itself. Okay, now what about this one? X to the fourth over y. Everybody see how we got x to the fourth? 5 minus 1. And then here you can see that you have 7 on the top, 8 on the bottom. 7 of them are going to cancel, leaving 1 extra in the denominator. Or you could have gotten y to the negative 1, which would make it go to the denominator too. Interesting to notice that this is the exact same problem, just inside parentheses. So we already simplified the inside, and that's what some of you were talking about, is like simplifying the inside first and then, you know, taking it to the power. So I already know that this is 3x to the fourth over 2y. Now I'll take that to the third, because notice that's the exact same problem inside. So what do we get? Now this is the exact same problem, but just taken to the negative power. So what do we do if I take all of this, the inside and to the third, if I take 27x to the 12th over 8y to the third, the only thing that's missing is the negative 1. You see how this problem builds, right? And so if I take it to the negative 1, what does it become? Yes, because you took the reciprocal, you flipped them. Good. Now notice here, we were talking about this earlier. A to the third times a to the negative third would be what? A to the 0, which is 1. Good. Here, this is the exact same thing. It's this multiplied by this. So what do you get when you do all of that? You get 1. Okay, that's because you're multiplying a number by its reciprocal. Anytime you multiply a number by its reciprocal, you get 1. End video.